Hello and welcome to the Security Dev Room. I hope everyone is ready for a talk on smart card forwarding by Daiki Ueno.
Yes.
Thank you. Welcome, I mean.
So hello everyone. Can you hear? Okay. Okay. So yeah, I'm Daiki from Red Hat. I'm working in. Okay. Okay. So yeah, Okay. So yes. So in this talk, I'll propose somewhat different kind of use case of smart cards that I call remoting. So here is the agenda. First, I'll quickly recap what are smart cards and how they are practically used, and then show the new use cases that's called remoting, and then look into the technical details of implementation. And if we have time, I'll show some demo, and then discuss the future plans of this project. So smart cards, maybe everyone knows what is smart card, but they can look in a different form factor, such as like usual banking cards or national ID cards, or it can be something like USB dongle, like USB sticks, and there are even software-only implementations, such as software HSM. So in our terminology, they can be often called as tokens instead of smart cards. So, okay, so yeah, so smart cards are basically a small computing device that can perform some crypto operations, such as encryption or decryption or creation of digital signatures or verification with. And also it provides some storage functions, such as certificate store, or it can also secretly store some private keys in there. So why in this age smart cards are still important? Because they can protect private keys inside the device itself, so it can prevent leakage of the private keys from the card to local file system or running process. So that's because all the private key operations, such as decryption or signing, can happen in the card itself. So it is very safe to use it compared to using the local machine to compute some crypto operations. So this is a common use case of smart cards. That is kind of user authentication with certificate and also signature generation inside the card. So first, application requests authentication to the system PAM service, and then one of the PAM module requests the smart cards to send back the certificate, and then PAM module verifies certificate, and then it asks the smart card to sign some arbitrary data, and then verify the signature. So after all, it's the user authentication succeeds. So, but it only happens in a single computer system. So I'm proposing to use it in cloud computing or remote settings, such as like this. So that is to allow some remote applications to use locally attached smart cards to authentication. Okay. So it is this is a one use case of the smart remote use case, that is user authentication, but it can be also used as other uses, such as protecting private keys for remote TL server, or making digital signatures for some build artifacts in a remote continuous integration server. Okay, so let's look into the implementation. So it's actually not so hard. It consists of 3 steps. First, we define the protocol to serialize the smart card access, and then somehow expose the protocol into some server, and then forward the forwarded server into the remote system. That's all. So let's look into the protocol. Probably most of you already know there is a standard C API called PKCS11. That is a library API implemented by some smart card drivers such as OpenSC or proprietary drivers. So basically, usually those libraries can be used from the application by calling dlopen and then call the functions defined in the library. So one of the example of PKCS11 API is this cfind object init. It takes 3 arguments and returns the status value. So in our implementation of serialization, we just maps into some byte sequences, yeah, like this. So we assign some call ID to this function that is currently 26, and also send some signature information. This is UAA. That means the first one, each session is mapped to the ulong value, and the second, the third one, sorry, the second and third ones are combined into a single array of attribute struct. So yeah, so like this. So it is very simple serialization form. So the complete implementation looks like this. The user starts the Unix socket server in the local side that bridges access to the smart card into the remote server. In the remote server, the system administrator installs the PKCS11 client module, and then application can use it to access to the remote smart card. So overall, the implementation it resides in the P11 kit project. That is a portable library. It is available in various distributions such as Debian, Fedora, some kind of GNU Linux distributions. And that mainly provides access to the multiple PKCS11 modules, and it also assures a multi-thread, and also it supports some URI that identifies PKCS11 tokens or some private keys or public keys on the smart cards. So it also supports some consistent system-wide configuration of PKCS11 modules. So let's see the demo. I hope this will work, but yeah. So P11, there is a tool that's called P11 tool that is from GNU TLS that lists some attached smart cards like this. Oh. So it takes time because actual smart cards is inserted. It is slow. So Yeah, there are 8 tokens attached to this system, and last 2 tokens have authentication capabilities. So let's use number 6 token. So I just specified the token with PKCS11 URI here. So then you see several public keys and private keys inside of it. So then forward this token into remote server. So first I'll create some server. Okay, now the smart card is exported into the run user some socket. Okay. So OpenSSH has a capability to forward the Unix domain socket into the remote server. So it is an OpenSSH extension, but it works. So I'm currently running a virtual machine on the local host with port 1025. So let's log in to it. So here I'm on the different user ID. So by default, this virtual machine doesn't have any token attached here. So there is only certificate store. So I now specified P11 kit client module. Then I can see the forwarded smart card here. And even I can use it from sudo command like this. So it seems to work. It is only for the first time smart card authentication happens. So we can use this later invocation of sudo. Yes.
When you enter the PIN, does it happen on the host side or on the server side?
Yes, it is. The question is the pin entered in here is asked by the clients local side or remote side, right? Yeah, it is remote side, unfortunately. So we are seeking for the solution about it. So yes, so there is some, yeah. So yeah, basically there are some future plans of this project. So first, the invocation of these commands are very complicated, and maybe we need to integrate it in OpenSSH or some Windows clients, and also more seamless integration with systemd would be possible, I guess. And yeah, as a question mentioned, there are some slight security implications, such as all the objects on the smart card can be visible in the remote side, I think it is not so secure. So we probably need to provide access control on it. And yeah, there are some operations that might not be useful in forwarding. So maybe we can disallow unused operations. And also, yeah, pin input is currently on the remote side. It can be stolen by the malicious servers. So maybe we can introduce some kind of two-factor authentication that intercepts the pin input in the protocol level in the local host side, and then some treatment in the local system in the some kind of sorry, system pin dialog in the desktop. Yeah. So also, I'm thinking of some kind of protocol standardization in near future. Yes. So that's all. Questions?
I have two questions. The first one is when you remotely enter the PIN code for the smart card, I guess it's on the remote server, and then you negotiate it using the socket that you forwarded. Instead of using this forwarding socket using the remote forwarding system in SSH, why not using the SSH agent forwarding? In SSH, you can just do a forward agent, and then you can negotiate the PKI in the local and not the remote server. It could be another ID instead of using a remote tunnel.
Yeah, that's a good idea, I think. Yeah, thank you. So,
any other question? I'll come to you.
I'm wondering whether there's a good rationale for the serialization of the protocol, because it seems to be binary representation, custom made. But I suppose other people have done remote procedure calls before, and I guess they've done it differently. Can you explain why you chose to serialize it the way you did?
Yeah. Yes, we are actually considering other format, but yeah, actually this format, this serialization format is currently already used in several cases. So yeah, maybe we should think about it, about those like JSON or something like that. Yeah, in some extensible way. Yeah.
There was one in the back.
Hi, I have such a question. For example, if you implement a proper API for that library and it will be stable, what if someone replaces that library with their own version that it always, for example, returns correct result, incorrect result, but application thinks that it's correct. Do you have some checks that library is valid or that's original version?
Yeah, there is a basic version checks because PKCS 11 API is standardized, so there is some checks what capability is not supported or supported in the local server. Yeah, yeah. Yes, but maybe we can add some mechanism to make sure the compatibility of the protocol. Yeah, somewhere.
Any other question?
Hi, there has been another project like this around 2 or 3 years ago, which is called PKCS 11 Proxy, which it was basically implemented in OCaml. I couldn't compile it ever. I didn't manage. Yeah, but they addressed the similar problem. So maybe you can look at that and yeah.
You want to go? Other question?
Thanks for the very good talk. We struggle a lot with chip cards where the pin card reader is actually a physical reader, like common in medical and banking industry, and to sort of like really sort of like force that the pin is not entered through the keyboard but through that keypad, because in software you sort of like have you have optional path. Are there sort of like any best practice advice or any ways we can sort of like this can help us keep that pin as close to the chip card and not travel far?
Yeah. I think it can be already bypassed the pin input if there is hardware pin input, but I have never tried it. But yeah, in the protocol level, maybe the client side can decide whether to send or ask the pin in the remote server, I guess. Yeah.
Any other?
Hey, thanks for the talk. I was hoping to find some solution for our local development environment. We're using smart cards for accessing private Git repositories in remote servers. And when I would want to move our building tools inside Docker containers, I'm not able to forward our smart cards into the Docker containers. Do you know if your tool or something else exists for this kind of problem?
Yeah. Yeah. I think another use case of this separation of the client server is network manager that runs the system demo as a root user, and it need to access the user smart card that can only be accessed through the specified UID. So yeah. Yeah, I'm actually not very familiar with the Docker, but there might be some way to tunnel the Unix domain socket inside the container. Yeah. Does it answer question?
We have 1 more minute for questions. Any other question? Okay, let's thank Daiki again. And we have a 5-minute break. Yeah. Very nice. Very good. When you're moving, I don't know if you showed before, it's, the video takes from here to there.
Uh-huh.
And here.
Yes.
And we start on time because the video will start on
Yes,
time.
I know.
So we cannot go earlier.